Good morning, good evening, good afternoon, boys and girls. So today's lesson is about a network topology that we will be working on, and later on we will complete this lab. We have PCA, PCB, PCC. All of them are in separate VLANs and different VLANs. We have a router connected to a switch 1, which in this case or in this scenario, we have switch 1 connected to switch 2. And that is our topology. We will be configuring this in Cisco Packet Tracer. Later on, we will add the configurations to the different devices and equipment. So let's move forward with the instructions. What I'm going to do is get the devices that we need. We need a router, we need two switches, we need three PCs, and a straight through copper cable. Mainly, the only The only time that we will be doing a crossover is between the switches, only between the switches. But most of the time we will be doing a straight through copper cables. So let's open Packet Tracer. Let's go ahead to our Cisco Packet Tracer, double click on it and wait for a moment. While we wait, let's take a look at the lab that we have prepared for you guys today. Let me see if I can. Some of the objectives we will be doing today: implement router on a stick for multiple VLANs, configure native VLAN on trunk links, configure DHCP pools for dynamic addressing per VLAN, secure access port with port security, configure ACL to restrict inter-VLAN traffic, test and troubleshoot common errors, mismatch for VLANs, run IPs, uh, shut down interfaces, extend topology to two switches with trunking and redundancy. Let's start with the lab. So now we have Cisco Packet Tracer. I'm going to work along with my other monitor so I can follow along this guide, what we need for this topology. And let's start with the PCs. We need the PCA, PCB, and PCC. Let's go ahead and rename them. So the first one will be PCA. This other one will be PCB. And this one over here will be PCC. Okay, what else do we need? What else? We need two switches. And these are, what kind of switches? 2960. So let's go to the icon for the switches. And let's put those guys. Now we need a router as well. So let me just go to the icon and look for that 2811 router. 2811 router. What else do we need? I think that's pretty much it. We have the devices that we need. Now let's go ahead and name these devices. This is SW1. This is SW2. Then you have R1, which is router 1. And that's pretty much. Next thing, we need to connect the devices. So remember, between switches, we use a crossover cable. Fast Ethernet 0/1. There you go. Then we have to be careful about the topology. And if you open the PDF file that I'm sharing with you, you will be able to see the connections that we need on this one. Is the setup guide. We need these connections. So follow along with the document and complete this. I'm going to do it anyways, but just for you to be aware that the information is there. First thing is first. So FA0 to 02, fast Ethernet 02. FA0 to fast Ethernet 03. Then we have FA5 to fast Ethernet 00. And finally, we have FA fast internet 02 to FA 0. Okay, that's everything. Now, let's do some writing because we want to be very organized on what we need here. So here we have VLAN 10. We can use capital letters, so it's more organized. Let me just select it and move it around a little bit. We have VLAN. What do we have here? VLAN 20. Great. Good job. Congratulations. We have VLAN 10 and VLAN 20. And let's go writing VLAN 30 here. VLAN 30. Remember, being organized is very essential and useful and important as well for when you are working as a network engineer in the field. Keep the order. Okay, what else do we do? We're going to add some information, some filling information. Let's start with the green color over here. Let's just add it there. And this will be the first VLAN. Let me just erase that one. The second color that we need here is a light blue. I like this one, so I'm just going to add it there. This light blue. Okay, I'm going to use this one for this case. Do you see? For VLAN 10, I need to move this around a little bit, but you get the idea, right? We're using this square, all the different squares to separate VLANs. And the last color is something like a red color. Yeah, it is a red color. So let's add that one. Let me just add it. Eventually, one day I will be able to. And let me just fill the color there. Let's do the square. I'm going to move it around. Give me just a moment, please. I want to organize this as well. So let me just put it there. Move it a little bit. There you go. Isn't that amazing? We have all the separate VLANs in different colors, and now we are more organized. Let us save our file with the network topology. So that is the first thing we do. I am in lesson 9, so network topology. And this is actually advanced router on a stick. Router dash on dash a dash stick. Okay, let's stop the recording for a moment. I mean the video. Let's stop the video for a moment so we can concentrate on the following. Actually, it doesn't really hurt if you see me or not. So what we need to do now is start adding the configurations to the different devices and equipment. Do you guys remember the easiest configurations that we have in this topology? And the way that we started, the first one, the PCs and devices. So let's do that. Let's go ahead and you will have a file with all the scripts and configurations for the equipment called ROS Advanced Config Bundle. So if you open the PCA notes, you will be seeing the information that we need to configure for that specific PC. 192.168.10.10, this is the IP address. Is a /24 for the mask. I will do it in a moment. 192.168.10.1 for the default gateway. 192.168.10.10 for the IP address. /24. And then we just close that one. If we do a connectivity pen right now, is a ping. If we do a connectivity ping and we send a ping to the 192.168.10.1, we will be sending a connectivity test to our default gateway. Probably the first one will fail, but the next one should be working, hopefully. Do you guys understand why it's not working? What do you think happened here? The reason because it's not working is because that router doesn't have a configuration yet, or the switch or the device where we are adding the default gateway configuration. So it will not work at this moment, but later on, we will be doing the connectivity test and it will eventually work. What will work right now? Our own IP address, 192.168.10.10. Our own IP address should be sharp, should be working essentially there. There you go. Now, let's go ahead and before we continue doing connectivity tests, let's finish that configuration. Let's go to PCC. Go to PCC node, and this is the IP address, 192.168.30.30. And 192.168.30.1 for the IP default gateway. There you go. And we have the last one. It's PCB. Let's go ahead and look for the PCB nodes there. The IP address will be 192.168.20.20. And then we will have 192.168.20.1 for the default gateway. Okay, next thing. We will go ahead and start adding the configurations to the different network devices. We have a switch, a layer 2 device, and a router, a layer 3 device. Basically, the routers operate at the layer 3 and the switches at the layer 2. So just keep that in mind. We will go into that later on. And I think we already covered a little bit about the OSI model. So if you hadn't get the chance to get the OSI model and the TCP model, please go ahead and review that lesson, the OSI model versus TCP. And it will be very, very useful for you guys to review that lesson. OSI model versus TCP IP. Okay, let's continue with this one. Guys, what do you think is the next step on the configuration for this equipment? Now, remember, we are network engineers in real life, and we don't have time to configure everything step by step, like taking too much hours. We have to configure everything. We already did our research, our investigation, and we already have that complete configuration for all these devices, for the switch, for the routers. So we just copy and paste the configurations and it will work. Now, even though we did the research, we did all this investigation and we tried to get the best configurations, there might be errors along the way. And if that happens, we will be here as network administrators or network engineers to fix those errors. So let me stop the video for a moment and the camera, so we can focus in the lab. Okay, time to work. Let's start with switch 1. If you open the file of the bundle and you copy everything that we have here from enable until end, you just copy this information, you click on copy, and you go to switch 1 very carefully. You click enter and you click paste. Hopefully all the information will work essentially with no errors. Let's take a look to what we have just configured right now with this script. Okay, we added the following in seconds. So you guys saw it took only like 20 seconds or less, maybe 10 seconds to copy and paste that configuration. Okay, we added the BTP mode transparent. Okay, there is a mismatch that will be covered later on when we configure switch 2. Do not worry about that. We have the following. We have a spanning tree by default. We have VLAN 10, VLAN 20, and VLAN 30, and VLAN 99. Users, creative, guest, and management, MGMT. We have the trunk configuration for switch 1 that goes to the destination, which is actually switch 2. we added VLAN access to fast Ethernet 02 and fast Ethernet 03. VLAN 10 is the one that will be allowed, in this case, via fast Ethernet 02. And VLAN 20 will be allowed on fast Ethernet 0/3. Finally, on fast Ethernet 0/4, VLAN 30. Now, that one, we don't really need it as much as I can see. This one is for a spare PC. Okay, I get it. So this one is for a spare PC. It means that in the future, if we want to add a PC here and we go, let me just go to the cables, add fast Ethernet 04 for that specific PC. That one is in VLAN 30. So let's take a look at the IP address for VLAN 30 here. So I can add another one. Maybe 29 will work. That's the big mystery. Okay. That's the big mystery because it's /24. We might have to do some subnetting to validate if that IP address will work there. Let me go ahead and do the validation real quick. So we have this network. We have this network and we want to add another PC. Okay, give me another IP address for this network, for an end device for this network. That's what I'm going to ask. Okay, give me the subnetting for this network. I just want to double check the range of the IP addresses that we have just to be 100% sure that we are not doing any errors there. So this is the first usable address and this is the last one. Okay, anything besides that is a very broad range of IP addresses. So we can use 30.2 and it will work just fine. So let's just add that one. 192, then 168, 192 and 168 at 30.2. Okay, and then 192 and 168 that 30.1. Do you guys remember? Do you guys remember what is the color that we are using for this VLAN? Do you remember? It's actually the yellow one. It's actually that one. So let's add it there so we can be more organized about it. And we can just copy and paste this text there, just for you guys to remember. Let's go ahead and name this PC like PC spare. PC spare is a spare PC. And that's pretty much what we need to do. Let me just move it around a little bit so it's more organized. I want to increase the size of that square if that can be possible. Will that be possible? Yeah, let's just go ahead and delete it and create it one more time so we can have a better option for that specific square. Let me just move this around. Let me just add a better square with more space. And let's go ahead and do the following. Let's add that VLAN there. Now we have two PCs for VLAN 30. Okay, let's see what else we have in this configuration. Show run. Despite this one, that is like the spare PC, we have that configuration from switch 1 to the router. And we are allowing all these VLANs, VLAN 10, 20, 30, and 99. In fact, the native VLAN is VLAN 99 in this scenario or example. Now, we have done pretty much an amazing job configuring switch 1, but we want to stop having those mismatch errors. You see the mismatch errors there? Because the switch 1 has the configuration, but switch 2 doesn't. So those are the errors. So let's go to switch 2 and let's go to the configuration of SW2 and copy everything that we have here until end. Let's just copy and let's paste it there. Let's just do a WR to save the configurations on both switches. WR, you see the restore, the consistency. It means we have successfully configured those devices and they are working along. They are communicating correctly. What else do we have? What else do we have here? So we have the router. The configuration of the router is missing. We have done pretty much all the job. Everything is working smoothly, but we hadn't configured the router yet. So let's go with the router. And let's just click here, no. And let's go ahead and do the following. Let's go ahead and go to the scripts that we have and look for the router's configuration. Again, we are doing the same. We are copying everything from enable until end. We just click in copy. We go here and paste it there. And then WR or copy running config, startup config to save that configuration. Now let's do a show run to see what we have just configured. We have configured pretty much all of the following. Let's take a look at this. We have the name of the router is R1. Some excluded IP addresses that we cannot use. Those are special IP addresses that we will not be using because those are for end devices like printers and PCs and all that. We have the DHCP pool to have automatic IP addresses, and the router will act as a server and provide IP addresses to the different devices. And what else do we have? What else? What else? I think that's pretty much. Now, what I want to validate, there is an access list to deny some traffic, specific traffic from this IP address, the 30.0, to the VLAN IP address, the IP address related to the VLAN configuration in the router. That's pretty much everything that we have done so far. This is the description from the connection of path Ethernet 0/0 to the switch. That's connection between the router and the switch. Though this is the DAT1Q encapsulation protocol running successfully. There is an IP access group 100 in to apply correctly the access list. And that's pretty much everything that we have. Do you guys think there is something missing? We will do some validation commands, but I want to learn something. I am a little bit curious about the DHCP. Is DHCP working? Let's test it here. Yeah, DHCP is working in PCC. Let's test it in this other one. What about this other PC? This spare PC? Nice. What about VLAN 10? Let's take a look at DHCP and see if it is working successfully. Great. And what about PC for VLAN 20? Let's go ahead and test it. Great, amazing. Now we can do the validation commands. So let's go ahead and see which validations we need to do. I'm going to go to the verification checklist and follow along with that. You will do the same. If you can please follow along with me. We are going to run some configurations and some validation commands. So first thing we go is to switch 1. And we do the following. Show interfaces trunk. If you do tab, it will autocomplete your command. So you can do that special trick to autocomplete commands. Use the tab key in your keyboard. Look at that, how beautiful. We have the trunking encapsulation successfully running on both fast Ethernet 01 and 05 of this first switch. Now, let's go ahead and run the following validation command. Show interface trunk in switch 2. Same thing. Show interface trunk, and there you have it. Now, what else? What are we missing here? Show VLAN brief. Let's do a show VLAN brief here. Show VLAN brief. Okay, great. And we will explain later on during the course what are the different privilege modes and the CLI related to the routers and switches. So do not worry about that. We will cover that in the next chapter, in the next section. So for now, we're just learning a little bit about VLANs and configurations and configuring PCs and routers and all that. But the different privilege modes in routers and switches, we'll cover that later on during this course. Okay, so we have fast Ethernet 02 for 30 for those guests, and that is in switch 2. That's the one we have. That's the one we have. The only fast Ethernet 02 connected to the PCC is successfully allowed in this device. Now let's do the same command in switch 1. Let's do a show VLAN brief, and here we have some devices. We have fast Ethernet 02 for PC A in VLAN 10, 03 for PC B in VLAN 30. We are allowing this. And finally, fast Ethernet 04, and you can see it there. This one is for the PC spare, being allowed for VLAN 30. What is the definition of VLANs for? Well, these are like different departments or segments within our switch, and they communicate with each other. Sometimes they are permitted to communicate with each other, sometimes they are not. It would depend in the customer needs and requirements. Next command, and now we are going to move to the router. Let's go to the router, R1. Let's do a show IP interface brief, and you can see all the IP addresses related to the encapsulation. Do you guys see the IP addresses there for the sub interfaces? Look at that. Look at that. Now let's do the following command. Show IP DHCP building. And this is a configuration that we didn't go into detail, but we will take a look in a moment. We have some MAC addresses, some IP addresses, and some types, which are automatic. Let's go ahead and take a look at the configuration with the show run command, so we can see where did we configure this binding. Let's take a look, because I don't remember that we have configured it, or maybe it's just by default there. Let's start from the beginning. So I see the router, I see the excluded IP addresses, I see the spanning tree by default, I see the encapsulation down queue. It looks like this configuration comes by default in the router, this DHCP venting. Oh, now I realize that we actually configure at some point DHCP, a DHCP pool. So there, the DHCP pool that we configure, this one is the one that gives us these capabilities of the DHCP binding command to successfully work. Look at that interesting detail. Once we configure the DHCP pool, the IP DHCP binding, show IP DHCP binding command will successfully work by default because of the pool that we configure. And this pool will allow the router to act as a server and provide automatic dynamic IP addresses to the end devices. Next, let's take a look at the access list. We configure an access list to permit all traffic and to deny some specific traffic. And we apply the access list in the interface fast Ethernet 0/0.30 with the IP access group 100 in command. So this is a standard access list. What we need to do now is the following. We need to run this command, show IP access list, and there you have it. Actually, it says extended IP access list. So let's go ahead and validate if this is a standard or an extended access list. I want to be sure about that. So let's do the question. Is this an extended or an standard access list? And do not worry about this because we will cover this in the program later on and we'll learn about it. In English, please. In English, please, because it doesn't understand that we are working in English right now. So your ACL is extended access list. Okay, so I was wrong. It wasn't a standard. It is an extended. Look at the values. Standard from 1 to 99. Extended from 100 to 199. There is another range from 1300 to 1999 and from 2000 to 2699. Those are the ranges for standard and extended access lists. Once again, do not worry about ACL because we will cover that in detail later on during this bootcamp. Let's continue with the lab. Are we missing something about these commands? What do you guys think? Well, there is a few commands that we're still missing. If you can see, there are some matches for this extended access list, and it means it's working. Now, show access list 100 is the command. This one, show IP access list to see all of them, but we can do show access list 100 to filter that specific access list that we configure. Confirm that 30 cannot reach 192.168.99.0/24. Let me see if we can do a test to confirm this. Let's go ahead and make the question real quick. Which test can we complete to validate this? And I think it's something related to the ping connectivity test, but I just want to double check and run the extra mile about that. It is taking a little bit of time, but I think probably something like a ping from router 1 to a specific IP address or something related of this matter will help us validate that the access list is actually working. So let's be patient and see if we can do the test. Okay, show IP interface gigabit 0/0.30 is the first command that we are executing in this router. Okay, it's not really working. Interesting. Okay, there are some tests that we can do. Some connectivity tests. If we go to a PC in VLAN 30, we will be able to do this connectivity test. So let's do it. Remember, sometimes the commands will not work because we are working in a simulator and it's not a real life environment. So that will happen. So nothing to worry. This one doesn't work actually because of the access list was successfully applied and added. So we did an amazing job applying the access list. Let's go ahead and do the following. Let's do a trace. Let me see, a trace route. It will be a tracer. It will be a tracer to 192.168.99.10. And this one actually works. This one actually works. Let's see why and what is happening right now. The expected fails is likely stopped at router 1. So, okay, so it looks like it is working for some reason. I'm going to ask that question in a moment to see if this, I want to validate this because apparently it's working, but I want to just validate just for a moment. Are we getting the correct information on this testing? The first one worked successfully, but we didn't get timeout in the second test. So that's what got me a little bit confused. Perfect. Those tests prove the block is working. Okay, so it's going to drop the traffic to 192.168.99.10, but it will still get to 192.168.30.1. So that's where we went. Let's do a show access list 100 to see if we have more matches for this connectivity test that we will be running. Okay, looks like we still have pretty much the same. Oh, no, we have 79 matches, 94 in total. So it means the access list is doing his job, is working successfully. Okay, if you want to clear the proof, we can do a clear access list counters. We can do connectivity ping test again, and so on. Now, you saw that when we were running the interface, it didn't really show us the information on this sub interface. But remember, which command will allow us to see these sub interfaces? Show IP interface brief. That will be the best command to look at those informations. So I think we have covered pretty much everything about this lab. Test the port security with more than 2 max. Let's see if there's a way to do this test. Let's go ahead and see if we can do this test. The mismatch of the native VLANs, the run encapsulation, the DHCP, usually those are some of the configurations that we have been doing so far. If we did something incorrectly, those are some of the troubleshooting scenarios that we will need to fix, but we have done an amazing job, so we don't have to really worry about those yet. What I want to do is this test. How can we complete this test? Because I know we added some security configurations there. Mm, okay. Okay, yes. I have to add some security to a specific port. So this is what I do. We go to an notepad. We copy and paste the configuration and remove this. We are going to add security to that specific port on switch 1. Okay. Now, this port in switch 1 is actually this other port, positive 04. So let's just go ahead and copy this and go to switch 1. Let me just close those. Let's go to switch 1 and add it there. Click enter, then enable, then config T, and then you just paste it there. What are we going to validate now with this configuration that we have just added? We added port security, maximum violation 2, port security violation shutdown, and port security MAC address sticky. We are going to run show port security interface FA02. And there you have it. The configuration of port security is successfully configured in our device, in our switch. That's the missing piece of the puzzle that we still needed to do. How to generate the traffic, connect a small switch for positive 02, then plug different PCs. small switch. Attach PCs on a little switch, then uplink to fuzzy ethernet 02. Let's see if we can do it. It's actually not 02, it's actually 04, but that guy doesn't understand. So let's go ahead and work on that. Let's just go ahead and do the following test. Let's add a switch, whatever switch. And let's go ahead and connect those between fuzzy ethernet 04 and fuzzy ethernet 04. And let's go ahead and add some PCs, maybe a couple of PCs, 1, 2, and 3. Let me just do it. And that will be a PC1, a PC1, a PC2, and then a PC3. We are just doing a test to validate if the port security is working or not. So let me just send this, fuzzy ethernet 01, fuzzy ethernet 02, and fuzzy ethernet 03. And let's go ahead and check this router to see if we are having a violation problem there. Show port security fuzzy ethernet. Are we having a problem there? Let's take a look. Enable, restrict. The main problem that we're having is a mismatch because of the switch, but I don't see a specific problem for that violation. Okay, let's look at fuzzy ethernet 04. Maybe I'm not. Oh, there you go. The violation shutdown is there. Remember, we were actually doing a fuzzy ethernet 04 instead of fuzzy ethernet 02. What I want to validate is to maybe if I just configure a PC to that specific port. Let me go ahead and clear everything here. I want to do a test right now. Let's go ahead and do the following. Let's do another test. Let's add a PC, whatever PC, and let's connect from Fast Ethernet 4 to this specific PC. Maybe I can do an IP address 182 and 168 that 30.3, 192 and 168 that 30.1. Now the idea is that this computer should be shut down at some point, but what I'm a little bit worried is that we can actually send ping and it's working. So wondering if we're still missing something or it is only allowed a couple of PCs to connect to this specific port. That's what I'm a little bit worried about. Let me see. Let me see if there's a way to get the restriction. I'm just going to stop the recording and do some research. Rosie, hey, violation shutdown. No entiendo por qué no funciona el violation shutdown. ¿Por qué no sirve el violation shutdown aquí? Let's see. You see it immediately. Attach 3 PCs to a little switch. Ah, 3 PCs. Okay, okay, okay. Okay, let me see. Let me do that. Mm-hmm. 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 Okay, so now I finally got the error. I have to do it like um adding different PCs. I added a laptop, I added another PC, then I erased everything and added a switch one more time. And finally I got the error of the poor security after a couple of attempts. So it has only like the option to add a couple of devices, maybe one or two devices, and then after that is exhausted, we will be getting the core security validation and the work will be done. Now let's go ahead and see if we can see that information. Show core security MAC show core security interface FA04. You see it is now shut down and you see the sticky MAC addresses and there is one violation there. We have successfully done it. It took a couple of attempts, like plugging some devices, plugging a switch. The first time didn't give us the error, but after the first time we added a PC, then we added a laptop, then finally we added a switch once again with the devices, and we got the error. So it gave us a couple of attempts to add some equipment and devices, but after um, a period of time of two specific attempts or three, it will start giving these error messages. And this is basically not an error message, but a violation count. We have one violation, and it's because we added a device that wasn't the correct device. Now, let's see what happened if we erase everything here, and if we go there to add the device, Facilitator 04 to that specific PC, and if we power down the port and power back on that port. Let's see if it works. Interface FA04. Let's do a shoot. Let's do a not shoot. And let's see if it works or not. I am seeing that for some reason it is not working. So we may have to remove the port security for that device or add something else. It was violation. Okay, now how can we fix the problem for that specific PC after doing the test? Let me just do some research on that. Mm, Recovery should not be down. Okay, should not shut down. Recovery cause P violation. Let me see. See. Hmm. Wow. Hmm. Extraño. Pum. The cover is not working. It worked, but the recovery is not working. Ah, okay. Let's see. No, it's not working. I might have to disable port security for faucet 0/4. Port security. Okay, yes. I at the end I have to disable port security. So I access the configuration mode, interface was Ethernet 0/4, no switch port security. And then after that, I did the not shut down, and then the shut down first, and then not shut down. And this is what happened. It finally worked. It is back online. And now it has the IP address again, and it is successfully working. So that was a little bit tedious because I even closed the lab and I opened the lab to see if it was a bug in the Cisco packet tracer. Sometimes that happen. But at the end, the solution that we got for this one was to um, remove the port security configuration. So what do we do in real life when this happens? We remove the port security, but then we add it again. So we go there, config T, and they just paste it. And then let's just save everything there. And now we have the port security again, protecting our ports and our devices. Show port security FA04. Let's see if I'm missing something. Interface, I'm missing the interface there. Okay, there you go. Now it's finally working. So be careful about that. You have the port security enabled. You have the two maximum of MAC addresses, and everything is back in place. So that's pretty much everything for today's lab. It was a little difficult, but we finally completed everything, boys and girls. I will see you at the top of success, and until next lesson, goodbye.